Welcome to the first lecture on work, energy, and power. You can get these notes at http://db.tt/capital M, capital O, 76, capital M, 69, lowercase g. In this lecture, we're going to look at two equations. W equals FD cosine of theta, where W is work, F is force, D is distance, and the theta is the angle. So work is in joules, force newtons, so that hasn't changed. Distance is in meters, and make sure your angle is in degrees. In other words, check your calculator when you're doing these problems that it's set in degree mode. Let me tell you about distance. Now, some books may say Fx, so x and distance are the same. So don't panic if your book that you're using has the Fx. Now the other one is P equals W over T, where P is your power, W is work, and T is time. So work and time are joules and seconds respectively, and power is in watts, which is abbreviated by the letter W. So be careful when you're doing this. You can see work, the W stands for work, but W also stands for watts, so kind of watch that. So we're going to look at a few problems today. It says, how much work does it take to push a 40 Newton box 3.4 meters? So we're pushing it, so we're going to assume that the force that's needed will just overcome this. You notice there's no angle here, so we're still using this. Just remember from your geometry days that the cosine of 0, which that's where you're going horizontally, is 1. So some books will say do that, and some teachers will say even though there's no, no angle, go on and put FD cosine theta, where you know this is going to equal to 1. It technically will not need to be there. Some books will say don't need it. So just kind of go with what your instructor asked for. So I've got work, so I'm going to push it 40 newtons and 3.4 meters. And so, like I said, no answer, but our units is in joules. So you can do that real quick calculation. Or we can say this one, that it took 450 joules of work, so there's your work, and there's our force, how far to how far, so D or X, and there's no angle. So I'm going to do it the other way without the cosine theta, since it's not needed in this problem. Now remember, joules is a unit of work, so that's 450 equals 23D, and D will be in meters. Just go back, check, and go back to your top. Now you can see this one, it has an angle, so we must use our FD cosine theta. So W equals FD cosine theta. Now if you think about it, from your free body diagrams, okay, I've got my box here, and I'm moving this way, but my force is that way. So some of your force is being directed up and directed outward, so to speak. But we're not looking at this part right here. We're looking at just the horizontal part, and this is where the cosine theta comes in. So W equals, I'm going to pull it. Now we could put friction in there if we wanted to, but just simplify things. And then the cosine of the angle. Do make sure that your calculator is in degree mode. and then work is in joules. And make sure that is a capital J. Don't try to script it or anything or make it a lowercase. That's other factors that is not representing joules. So joules a capital J. Okay. Let's kind of look at this. Now you can see I've got how much work, there we go, how much work can a 100 watt, okay, now you think, oh, work. Nope, it's watt. That W means watts. So there's your power, and there's time. So power equals work over time. So there's 100. Now I'm looking for the work. Now remember, time is in seconds, so I have 1 hour. So there's 60 minutes in an hour and 60 seconds in a minute. And you should be able to do the math and work. Too many W's in this one, didn't it? Work will be in joules. And you can see here, here's another one using the watts. I've got a 10,000 watt motor. It's going to perform 3,200 joules of work. So there's work, there's power, and I want to know how much time. So power equals W over T. So it's 10,000. There's the 32,000 over T. And if you look at the top, T will be in seconds. So that's pretty much it. Real nice and simple. So just remember on this one, your teacher might have you use the X, which is appropriate. That's okay. And don't forget, if you're using in your calculator and you need this, make sure that your calculator is in degree mode and not radian mode. If you have any questions, don't hesitate to contact me.